In this video, we're going to be dealing with the reflection of light, and we're going to talk about reflection in a plane mirror and teach you to draw ray diagrams of reflection in a plane mirror, step by step. So when light reaches a mirror, it reflects off the surface of the mirror. Reflection means it bounces off the surface, forming an image of the object. What you see in the mirror is just an image of that object. So let's go through step by step how we use a ray diagram to show how reflection occurs. The first thing you need to know is the symbol for a mirror is a straight line with diagonal lines showing the back of the mirror. This is called a plane mirror because it is a flat surface that is reflective, shiny surface. That image there that you see there is the symbol for a mirror. The first thing we need to do is draw in the object that is on the reflective side, the front side of the mirror. So there we go, we've got a candle, and that is our object. It could be any object. From a point on the object, we draw a ray of light. The rays of light will travel from all the different points on the object. We just choose one point and draw the ray of light towards the surface of the mirror. I've chosen to draw the ray of light from the actual flame of the candle. We show the direction that the light is traveling in with an arrow. Obviously the light is traveling from the candle towards the mirror. And we call that ray of light the incident ray. Then we draw a dashed line at 90 degrees to the mirror, and this line must cross the mirror at the same point that the incident ray hits the mirror. This line is going to be what we call our normal line. So there you see our protractor. We draw in our dotted line at 90 degrees to that mirror. The angle there, it is perpendicular or 90 degrees to the mirror. We call that our normal line. It's an imaginary line at 90 degrees to the mirror. The angle of incidence is the angle between that normal line that we've just drawn and the incident ray. So we can label it on this diagram, the angle of incidence. Be careful not to ever draw in the angle of incidence between the mirror and the ray. It is always between the normal and the ray, the incident ray in this case. And often you'll see it indicated with an I, a small letter I. The law of reflection states that the angle of incidence is equal to the angle of reflection. So when we now want to draw the reflected ray, we need to get our protractor and measure the angle of incidence. And using this protractor here, I can see that there is from 90 to 100, 110, 120, 127. So that's 37 degrees, the angle of incidence. So we measure 37 degrees from backwards from 90 and then mark in where the reflected ray would be. And you can see those little blue lines showing where 37 degrees from the normal line towards the mirror, so that those two angles are equal. Once we've done that, we're going to draw in the reflected ray, connecting up those little blue lines to make our reflected ray, which is 37 degrees. This one happens to be 37. Obviously it can be any angle, but those two angles, angle of incidence and angle of reflection, must be the same. So we draw in our line again, and this is called the reflected ray, and we show the direction that the ray is traveling in. Then we can label the angle of reflection between that reflected ray and the normal line. That's called the angle of reflection and is indicated with a small r. If a person was looking into the mirror, the reflected rays of light would bounce off the mirror and enter the eye as shown in this diagram. So then what we do is we draw a dotted line behind the mirror showing where the virtual rays of light would appear to be coming from. we basically extend that reflected ray backwards, and the dotted line shows those virtual rays of light. Once we've extended the ray backwards, then we draw in the image of the object that appears in the mirror. That image will be laterally inverted. The image is the same size and it's upright, but it's inverted laterally, which means left is right and right is left. It is what we often use the phrase a mirror image. And the last thing that you need to know is the distance of the object in front of the mirror is the same as the distance that the image is behind the mirror. So if we indicate this with an arrow, you can see that distance from the mirror to the object should be the same as the distance from the mirror to the image. And that is how to draw ray diagrams to show reflection.